Hello everyone. In the second part of this particular video, which is on 11th standard maths for ISC board, we'll be covering say 5-6 questions. Let us understand the first question. If tan theta plus sin theta is equal to alpha and tan theta minus sin theta is equal to beta, then show that alpha square minus beta square is equal to 4 root square root of alpha beta. Let's start with the left hand side, which means you have to show alpha square minus beta square. For that, we will first take alpha, which is tan theta plus sin theta. We will try to square on both sides. This will become alpha square is equal to tan theta plus sin theta as a whole square, which is tan square theta plus sin square theta plus 2 sin theta tan theta, which means a square plus b square plus 2ab. Similarly, we will take b as tan theta minus sin theta. We'll make beta square tan theta minus sin theta square is equal to tan square theta plus sin square theta minus 2 tan theta sin theta. What we will do is we will subtract equation 1 from equation 2. We will get alpha square minus beta square. This tan square theta will get cancelled. Sin square theta will get cancelled. And we will get 2 minus 2, which is 4 sin theta tan theta. That is the left LHS. Now we will take RHS, which is 4 square root of alpha beta. We will put alpha and beta here. 4 square root of tan theta plus sin theta into tan theta minus sin theta will be equal to 4 square root of, this will become a plus b into a minus b as a square minus b square. This will become tan square theta minus sin square theta. Now this can further be written as sin square theta upon cos square theta minus sin square theta, which is 4 square root of sin square theta into 1 minus cos square theta upon cos square theta, because you're taking the LCM. 1 minus cos square theta can also be written as sin square theta. This will become 4 square root of tan square theta sin square theta, which can be written as 4 tan theta sin theta, which is what we have got in equation number 3, and hence proved. Let's take the next question of trigonometry. If A is in fourth quadrant and cos A is equal to 5 by 13, find the value of 13 sin A plus 5 sec A upon 5 tan A plus 6 cosec A. First, you have to understand that it is in fourth quadrant. In fourth quadrant, cos is positive and sine is negative. This is sin, sine is negative. Now here, cos A is equal to 5 by 13. We can either use the triangle law, which I have taught, or we can use identities. Using identities, we know that sine A is equal to root of 1 minus cos square A, which will become root of 1 minus 5 by 13 square, which is root of 1 minus 25 upon 169, which is 144 upon 169 ka root, which is 12 upon 3. Now in the fourth quadrant, since sine is negative, this is going to be sine A is equal to minus 12 upon 30. Now we've got value of sine, we've got value of cos. We can find out any other value. So first we need sine, then we need sec. Sec is reciprocal of cos, so this becomes 5 by 13 is cos. Sec will become 13 upon 5. Last is tan. Tan A is sin A upon cos A. When you divide this, you will get minus 12 upon 13, divide by 5 upon 13, which is minus 12 upon 5. So you've got all the 4 values, that is sine, sec, tan. You also need cosec. Cosec is reciprocal of sine, which is minus 12 upon 13. This will become minus 13 upon 12. We will input all the values here. 13 into sine A plus 5 sec A upon 5 tan A plus 6 cosec A. 13 into minus 12 upon 13 plus 5 into 13 upon 5 upon 5 into minus 12 upon 5 plus 6 into minus 13 upon 12. We will cancel this 13, 13. We cancel this 5, 5. We will get minus 12 plus 13 in the numerator. We will get minus 12 and minus 13 upon 2 in the denominator. This will become 2. So you will solve it further. You will get minus 2 upon 37. The third question is, prove that 4 by 3 cot square 30 degree plus 3 sin square 60 degree minus 2 cosec square 60 minus 3 by 4 tan square 30 is equal to 3 1 by 3. This is pretty simple. Directly substitute the values. So you know that, let's take a left hand side. 4 by 3 cos square 30 plus 3 sin square 60 minus 2 cosec square 60 minus 3 by 4 tan square 30. You know that tan 30 is 1 upon root 2, root 3. So cos 30 is root 3. We'll take the square of that. Sin 60 is root 3 upon 2, square of that. Cosec 60, you know that sin 60 is equal to root 3 by 2. So cosec is reciprocal, it is 2 upon root 3. And tan 30 is 1 upon root 3. Sabka square likha yahan pe. This will become 4 by 3 into 4 3 into 3 by 4 minus 2 into 4 by 3 the square and minus 3 by 4 into 1 by 3. This 3 will get cancelled. This 3 will get cancelled. We will get 4 plus 9 by 4 minus 8 by 3 minus 1 by 4. This can further be kept together. You will get 25 by 4 minus 13.5 by 12, which can further be reduced to 40 by 12, which is 10 by 3, which is 31 by 3, which is RHS. Let's take the fourth question. It's again pretty simple. Only thing we need to remember is the sine and cos laws for all the 4 quadrants. As I told you initially, both sine and cos are positive in the first quadrant. Both are negative in the third quadrant. Here, x is positive, negative. It means cos is negative and sine is positive. Here, x is positive and sine is negative. So this is how we remember xy, xy, xy in fourth quadrant. Now, sine 90 minus theta is cos theta. Sec 180 minus theta will come into second quadrant where cos is negative. So this will become minus sec theta. Sine of minus theta is minus sine theta. Sine of 180 plus theta is in third quadrant. Again, minus sine theta. Plus cot 360 minus theta. It is in fourth quadrant. Again, minus cot theta. And cosec 90 plus theta is in the second quadrant, which is sec theta. Again, positive. This minus sec theta, this sec theta and sec theta will get cancelled. Then you will have sine theta and sine theta, which is cancelled. Minus minus sine will also become plus. What you will get is cos theta upon cot theta, which can be written as cos theta into tan theta, which is nothing but sine theta. This is what we had to prove. In the fifth question, it is tan b plus c plus tan c plus a plus tan a plus b upon tan pi minus a plus tan 2 pi minus b plus tan 3 pi minus c is equal to 1. Here I want to use the SOMAT. That is, we know that a plus b plus c is equal to 180 degree. Sum of the angles of a triangle is a measure of sum of angles of a triangle is 180 degree. So a plus b plus c is 180, which can be written in terms of pi as in radians as a plus b plus c is equal to pi. Therefore, I can write b plus c is equal to pi minus a. Similarly, I can also write a plus c or c plus a as pi minus b, and also a plus b as pi minus c. We will substitute all these 3 values in the numerator. Here we will get tan b plus c plus tan c plus a plus tan a plus b. Now, if I substitute here, it will become tan pi minus a plus tan pi minus b plus tan pi minus c. Now, we all know that in this second quadrant, tan is negative because one is positive, one is negative. So this will become minus tan a minus tan b minus tan c. Similarly, the denominator will also become tan pi minus a will become minus tan a. Tan 2 pi minus b will be in the fourth quadrant. Here also tan is negative. It will become tan minus tan b. And tan c again in the second quadrant. This will also become tan minus c. You have to remember the quadrant rule. So this will become 1, which is RHS. The last question for this particular exercise or this particular set of important questions is if sec theta is equal to root 2 and theta is 3 pi by 2 to 2 pi, which means it is in fourth quadrant, find the value of 1 plus tan theta plus cosec theta upon 1 plus cot theta minus cosec theta. So first we will have to find out from sec theta other values. So you can say sec theta is equal to root 2. Fourth quadrant cos is positive, so sec is also positive. 1 plus tan square theta is sec square theta. So tan square theta will be equal to sec square theta minus 1. We will input the value of sec theta as root 2 square minus 1, which is 2 minus 1, which is 1. So you have got tan theta is equal to plus or minus 1. Now tan theta will be negative because in fourth quadrant tan is negative. So tan theta is equal to minus. We got tan theta. Further cot theta will also be minus 1. We know that cos theta is equal to 1 upon root 2 because sec is root 2. Therefore, sin theta will be root of 1 minus cos square theta, which is equal to root of 1 minus 2, which is 1 upon minus 1 upon root 2. Now minus sign is because sin is also negative. So if sin is negative, definitely cosec will also be negative. So cosec is minus root 2. So we've got a value of cosec, we've got a value of tan. We have also got a value of cot. We'll put all these 3 values here. 1 plus tan theta plus cosec theta upon 1 plus cot theta minus cosec theta. This will become 1 minus 1 plus minus root of minus 2 upon 1 minus 1 minus root of minus 2. 1 minus 1 will get cancelled. Minus root 2 upon minus 1 plus root 2, you get minus 1. That's all. These are the 6 questions in part 2, and there are few questions which I've covered in part 1. Please go through these. Do subscribe to our channel, and all the best for your exams.